Hello everyone. In this video, we're going to learn about the rate of change, average rate of change, and concavity. Alright, so first we're going to talk about the formula of the average rate of change. So, first we need to draw a secant line. This secant line intersects the graph at 2 points. A and B. So S equal A and S equal to B. We have f of A right here. And we have f of B right here. Alright, so the formula for the average rate of change is going to be f of B minus f of A over B minus A. Alright. Now let's take a look at the first example right here. We need to find the average rate of change for the linear function. Alright, so basically this is actually the slope of this linear function. Okay, so we're going to use the rise over run, right? So the slope of this one is going to be rise over run. Alright, so we pick a point right here. We pick a point right here. Okay, rise go down. It's going to be negative 2. Now go to the left 3 units. It's going to be negative 3. And we're going to simplify. It turns out to be 2/3. Alright, so if you pick another 2 points right here, you still get 2/3. Okay, so actually the average rate of change for this linear function is 2/3, which is the slope of the line right here. Alright, now we do the same process. We will get the average rate of change for this guy should be negative 2. And this guy should be 0. The horizontal lines, the slope is 0. Alright, don't forget the Christmas tree trick. This guy's slope is positive. This guy's slope is negative. The horizontal line slope is 0. And the vertical line slope is undefined. Alright, now we need to find the rate of change of the average rate of change of each of these linear functions right here. Okay, so we have the average rate of change of this linear function is going to be 2/3, right? So every single times we have 2/3, 2/3, 2/3, right? So we need to find the change of this one right here. It's going to be 0. The change of this one is going to be 0. So the rate of change of the average rate of change of this linear function is 0. Now we do the same thing. This is negative 2, right? So the average rate of change is negative 2, negative 2, and negative 2. So the change between this guy and this guy is going to be 0. The change between this guy and this guy is going to be 0. So the rate of change of the average rate of change of this linear function is 0. Alright, same thing. This guy 0, 0, 0. So the rate of change of this guy should be 0. So the rate of change, in general, the rate of change of the average rate of change of a linear function is 0. Alright, let's move on to the quadratic function to see the difference. Alright, so this is the quadratic function. Okay, now we need to find the average rate of change over the interval 1, 2. Alright, so x equal to 1, y equal to 2. So this is the interval we need to calculate the average rate of change. So by the formula right here, okay, when x equal to 1, y equal to negative 1 right here. Alright, so we have the point 1, negative 1. Now when x equal to 2, y equal to 0. So it could be 2, comma 0. Now we're going to apply the formula right here. So the average rate of change is going to be 0 minus negative 1. It should be 1. 2 minus 1 is going to be 1. So the answer must be 1. Now next one. Interval 2 to 3. So x equal to 2. Y equal to 0. So we have the point 2, comma 0. Now x equal to 3. Y equal to 3. Right here. So we have the point 3, 3. Now the formula average rate of change equal to 3 minus 0 is going to be 3 over 3 minus 2 is going to be 1. So the answer must be 3. Now over this interval 3 and 4. So x equal to 3, y equal to 3, right? So we have the point 3, 3. X equal to 4, y equal to 8. Right, so it could be 4, comma 8. Now the average rate of change is 8 minus 3, which is 5, over 4 minus 3, which is 1. So it could be 5. Alright, now we need to find the rate of change of the average rate of change. Alright, so the first one right here we have 1. The second one right here we have 3. The third one right here we have 5. Alright, so we need to find the difference between this guy right here. Right? Should be 2. This guy should be 2. And we look at the input intervals right here. Alright, they all have the same length. Right? So the rate of change of the average rate of change of the quadratic function is 2 right here. Okay. Now the average rate of change for a quadratic function does not stay the same. Look, the first one is 1, the second one is 3, and the next one is 5. For consecutive equivalent input value intervals, the rate of change, which is this one right here, of the average rate of change of a quadratic function is constant. Alright, for this problem, the rate of change of the average rate of change is 2. Now, let's move on to the next one. If you're given the graph like this, and the question asks you to determine if the function is increasing or decreasing, and if the rate of change is negative or positive, or increasing or decreasing. So how do we do this? So let's take a look at this one. Alright, so suppose you have the graph like this. Now, you get the x and y coordinate. Alright, now I pick a point right here. I pick 2 points. You see that the graph going down. So I pick this point. Right? I have x right here and I have x right here. Y right here and y right here. And you see that when x go into infinity and then y values going down. Right? So which is the function is decreasing. So if the function decreasing, what happened to the rate of change? Okay, so we sketch a tangent line each time. So the tangent line is going to be like right here. It's steeper. And then it's getting less steep right here. You see that? It's getting less steep. And finally, it's getting to 0 right here, which is the horizontal line right here. Alright, so we see that if we look at this one, the graph going down like this, the slope is negative. Okay? And it's getting close to 0, which is the slope is increasing, right? It's increasing from negative to 0. So the rate of change is negative, right? Because you see that this guy is going down right here. And the rate of change is increasing. This is actually increasing from negative to 0, right? It's getting less negative, right? Now, if the rate of change increasing, the function is concave up. Now, if you see the U shape like this is concave up, okay? Here's the trick for you to memorize the U right here, up, right? Like this, concave down. Concave down, think about this letter right here, okay? Now, next one, the second one right here. So, if you observe, you see that the first two right here, this is actually the left half and the right half right here. I cut this one in half. The left half, which is this guy. The right half, which is this guy right here. You see that? Okay, so in this situation, the function is still concave up. Alright, if the function is concave up, the rate of change is increasing. Alright, now we get x and y coordinate. Alright, now the function goes from left to right. Alright, pick 2 points right here. Okay, project down to the x-axis. So you see that x goes to the right, and then the y values goes up, right? So which is the function is increasing because the y values is increasing. Alright, now if the function is increasing, the rate of change is positive. Okay, we just draw a tangent line. We will see it. Alright, the tangent line. Like this, and like this, like this, this. And you see that the tangent line looks like this guy right here. So the slope is positive. Okay, the rate of change is increasing because the rate of change starts at something right here, which is 0, right? And it's getting more positive, right? It's getting steeper and steeper, steeper. So it's getting more positive. Alright, so the rate of change is increasing. Alright, let's move on to the last two right here. So the last two right here, which is the bottom one right here, concave down right here. Alright, the first one, which is the right half right here. And the last one right here is the left half right here. Alright, so we see that the function is concave down. This is concave down. Alright, now we need to understand if the function is increasing or decreasing. So we're gonna sketch a x and y coordinate. Alright, we're gonna pick 2 points right here and right here. Okay, the first point right here, this is S1. The second point, S2. You see that S go to infinity. The y value going down right here. Alright, so the function is decreasing because the y value is decreasing. Now, because the function is decreasing, the rate of change is negative. We can check it. Right? Now, the rate of change starts right here, which is 0 right here. The horizontal line right here, the rate of change equal to 0. And then it's getting more negative and more negative right here. Right? So it's going down right here. It's getting more negative, which is negative. Right? Now the rate of change is decreasing because it starts at 0 and it's getting more negative like this. Right? Now the last one, we do exactly the same thing. The function in this situation is increasing. The rate of change is positive. Because the function is concave down, the rate of change is decreasing. Alright, keep that in mind. The function is concave down, the rate of change is decreasing. If they give you the rate of change is decreasing, you can conclude the function is concave down. So this guy implies this guy. This guy implies this guy. Same thing. This guy implies this. This guy implies this. So you're going to put the equivalence right here. Now let's take a look at the example right here. The graph of chi of x is shown above. Use the graph of chi to find intervals where chi has the following behaviors. Now first, you need to understand when you include the endpoint or not. When it comes to increasing or decreasing, you must include the endpoints. Which means we're going to use the bracket like this or like this, because the endpoint is still inside the decreasing interval or decreasing interval. But when it comes to the concavity, alright, you need to exclude the endpoints. Which means we're gonna use the parentheses like this, because the point of inflection is not in the concavity interval. So, question A right here. The function g is increasing. We look at the table on the left right here. Okay, we know that the function is increasing from here to here and from here to here. Okay, so the answers must be bracket negative 3 and 2 union. Which one? 4 infinitive. Alright, now the next one. The function g is decreasing. So decreasing, which is this one right here. And this one right here. Alright, so it's going to be negative infinitive 2, negative 3. The brackets right here. The brackets right here. Union 2, comma 3. Bracket. 4. Bracket. Now, next one. G is concave up. We look at this one right here. Concave up, which is this guy and then this guy. Alright, so concave up. Now refer to the table on the left hand side. So the function is concave up. It's going to be this guy. And from here to here. Alright, so it's gonna be negative infinitive to negative 0.5. You don't put the bracket, you must put the parenthesis right here. Because this guy is the point of inflection. Union 3 to infinitive. Alright, let's move on to the next one. The function g is both increasing and concave up from here to here. This is increasing, and this is from here to here. Alright. So after we identify the increasing interval, we need to look at the concavity. So concave up, which means from here to here only, and here to here. Alright, so it could be negative 3, comma, negative 0.5, union 4 to infinitive. Now, since the function is increasing, we can include the endpoint. But because the function is concave up or concave down, so we need to exclude the endpoint, so we don't have the bracket in this situation. Now, the function is concave down. The function is concave down. This is from negative 0.5 to 3 right here. Alright, so this is the interval where the function is concave down right here. Okay, so it's gonna be negative 0.5 to 3. Alright, and the last one, the function both decreasing. Okay, so decreasing, which means this guy right here. This guy right here. Okay, and concave down. So this guy concave up. This guy right here, concave down right here. So concave down is going to be from here to here only, because this guy right here concave up. So it's going to be from 2, 3. Alright. Now the last one, if the question gives you 4 of this, and the question like this, the graph of f of s is decreasing at an increasing rate. Alright, so this is a complex sentence. We need to break it down into 2 simple sentences. Now, the first sentence should be the graph of f of s is decreasing. This is the first one. Go over here. Now, the second one, the rate of change is increasing. Alright, so we look at the table right here. The graph of f is decreasing. So either the first one or the third one right here. Next one, the rate of change is increasing. So the rate of change is increasing, which means the function is concave up. So the answer must be the first one right here. Alright. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young